I'm Dr. T and welcome to my office. Today I would like to talk about dissolving. So when you have and I'm just going to go for the standard solid into a liquid. Although what I'm saying doesn't necessarily have to apply to just solids. So if you have a solid, it's going to have a bunch of atoms or molecules all clumped up together. And actually there's two classic solids I'd like to look at. The first one is sucrose. So in this case, we've got some molecules. They have 12 carbons, 11 oxygens, almost 24 hydrogens. And they're, nice little clumps. And then these all interact with each other, and you get your nice little sugar cube. Now, when that dissolves, and in this case, it would dissolve well in water because both of them have similar intermolecular forces, the water will start surrounding the sucrose molecules. And so you'll get what we call a sphere of hydration, and the water will surround it, and it kind of takes the molecule off, and it floats around in the water, and it slowly breaks apart the sugar cube. Now, if we compare that to the way sodium chloride or table salt dissolves, it starts out very similarly, except for the fact that sodium chloride is an ionic compound. It's not discrete molecules. Instead, you have chloride ions and sodium ions. So the water will surround them. The water will typically put the oxygen near the sodium anions because the sodiums are positively charged and the oxygens have a slight negative charge. Opposites attract. Likewise, the hydrogens, which have a slight positive charge, will be attracted to the chlorides. The water will surround them in the same motif as described earlier, but much more dramatically, and they'll start pulling them off. But instead of having sodium chloride molecules, because those are not a thing, you have sodiums floating around, surrounded by water molecules, and you have chlorines, or chlorides, surrounded by water molecules floating around. The fact that you have charges floating around allows them to move, so things that will produce ions in solution are known as electrolytes. Most of your electrolytes are ionic compounds, but not all of them. Things like some of your acids are molecular compounds, but they do kind of split because, once again, nature doesn't conform to our boxes. We simply try and conform it onto nature's. And thus you have your dissolving. Now, if you try and mix, say, sugar with oil, which is, of course, a classic step in baking, you take your sugar, you put it with your oil, and you beat it up, the sugar doesn't dissolve. Instead, the oil kind of goes around your sugar grains, but because the oil doesn't have similar intermolecular forces as the sugar does, then the two don't really like to interact with each other. This is why we say like dissolves like. Similar intermolecular forces will interact well with each other. Dissimilar ones, not so much. And thus, oil and water, oil and sugar don't particularly mix. So yeah, a brief thought on dissolving solutions, or dissolving things into solutions, and I will see you on later videos. Have a wonderful day.